Mic check, mic check. I don't know if this is working. Okay, I'm going to try to film this for anyone who's absent. We're going to cover a number of topics that have to do with polynomials. But I wanted to share with you something called the fundamental theorem of algebra. And you might be wondering, wait, if it's so fundamental, how come we aren't learning about it until Algebra 2? I don't know. I don't know why they do that. But here it is. A polynomial of n degree, or of degree n, we could call it, has n roots. Now, roots are the numbers you can put into a polynomial function that spit out zeros. And they are also related to the x-intercepts, and they are related to the zeros, they're related to the factors. So what does it mean to have n of them? N some number. So let's do an example over here. I have a polynomial of degree 7. Let's just make it super simple. X to the 7th. This has 7 roots. Now, what are they? Well, what will make this 0? What will make the function spit out a 0? 0. So 0 is the only root, but it can be put in 7 times because x to the 7th means x times x times x times x times x times x times x. Look, there's 7 places to put that 0. So we call that multiplicity. We say that its root is 0, multiplicity 7, like 7 times over. Okay, so sometimes, let's put some bullet points here. The roots can be complex. In other words, they're not on the real number line. They have an imaginary component or a complex component, and they're not on our regular number line. So this could be complex. We won't see on graph. Okay, and then sometimes roots are repeated. Which we call multiplicity. Every once in a while I just like to show you something that you don't have to write down. The last period was making fun of me, so I'll put it on the board so you know this is optional. I just wanted to explore a little bit about roots because where does roots come from? We know that okay, that's the number you put in and you get out a 0, which makes it an x-intercept. But what is really going on? Well, imagine a polynomial that was like 5x squared minus 3x plus 5 equals x cubed minus x. here's some relationship. This is an equation. This is an algebraic equation. Equal sign's doing a ton of work here. It means whatever number you put in for x and crank it out on this side, you have to put that same number on the other side, crank it out, and it has to equal. They have to equal each other. There's some numbers, let's find them. Let's find those x's. What are the solutions? What are the x's that work for this? Well, that is the same as asking this other question, which if you do some algebraic manipulation, and now that you're in algebra 2, you can actually do two steps at once. So I'm going to subtract x cubed and add x to get rid of both of those. And we get negative x cubed plus 5x squared minus 2x plus 5 equals, what's left over here? 0. So the first question, which is what x's can you put in here so that it is equal, is the same question as asking what x's can you put in here so that it's 0. But now everything is gathered together, so it's more concentrated. So this is like a more pure form of this question, this original equation. And now that it's in its more pure form, what are the essential components that build it? What are the numbers that you can put in for x to solve it? Which means you'll be finding roots. So that's why roots are important. When you take any algebraic relationship and you simplify it down to something equaling 0, and you want those answers, that's where the roots come from. Okay, let's do an example. Let's make a function. Really? Right in the middle of the notes, Timothy. All right, is this function in standard form? Alden.
No.
No, it is not in standard form. Do you know what form it's in?
Factored?
Yeah, this is factored form, which is nice because factored form will tell us where the zeros are. But it's not nice because it doesn't tell us what the degree is. Because remember, the degree of the polynomial is the highest exponent when written in standard form. But now, could we multiply this out and get it into standard form? We have the technical skills. Would that be annoying? Yes, that is a ton of rainbows. That's a lot of multiplying, right? Can we figure it out? So the first two would be 4, and then there'd be 8 or 6. So we're talking like something around the order of like 30 multiplication steps and combining like terms. That's like a lot. Just to figure out the degree, and we'd get the y-intercept also for free. The last term would be the y-intercept. Is it possible that we could just focus on the lead term? Like, what will become the most powerful term? So, okay, you guys can make fun of me, but don't write this down. But let's see what would happen if we started to multiply this out. This is the whole thing written out, and we know that we would do this rainbow, and we get x squared, and then we get some other stuff. And then we would eventually do this rainbow, and we get x cubed, and we get some other stuff. And then, I didn't bring all these down. Maybe you get the point by now. The very lead one is just stacking up what happens when you multiply the front part of the binomials together. And so 1, 2, 3, 4, 5, 6, we will have x to the 6th. And then there'll be lots of other stuff. I mean, the polynomial will go on for quite some time, and then there'll be a last constant term at the very end. But look, we know the degree now. We know this is a 6th degree polynomial. So let's write that down, degree. Okay, what's the sign on the lead coefficient? Well, again, we don't have it in standard form, but we can imagine if we multiplied all these together. I mean, we got our first term. It's going to be x to the 6th, and that would be a positive 1 in front, so it's a positive sign. So for the end behavior, on today's assignment, you can draw a picture. What is this going to look like, James? James front row.
Okay.
Okay, it has an even degree, which is like a quadratic. What's the behavior on both ends for something that's like a quadratic? Yeah, they'll both go up, unless it has a negative lead coefficient, then they'll both go down. But they both go the same direction. Then you just have to figure out which direction is that. It's up in this case. So you can draw a squiggly picture. The technical way, of course, is as x goes to negative infinity, f of x, or a student asked me if they could switch to y since they saw that on one assignment. Y goes to up, and as x goes to the right, y goes to also up. But I will accept this, because this really gets at this is the important part. In fact, maybe in another 200 years we'll stop writing all these weird symbols and mathematicians will just talk to each other in squiggles. I mean, this could be the symbol if you guys start popularizing it. So get on that, right? Desmond's not with me. All right. Well, what's left? What do we need to do that's left? We just need to sketch. Oh, we need to talk about the roots. What are the roots? With multiplicity, aka the zeros. So on the assignment today it says zeros instead of roots, but I like roots better. More old school. What is one of the roots of this? Rocco? -4. And now here's our new learning for the day. What's the multiplicity of that root? How many repeats does it have? 3. So we can write m dot 3. And again, if you want to make that concrete, look at this. When we started to multiply it out, look, there's 3 places to put -4. Put -4 there, -4 there, -4 there, -4 there. Now, yes, you also have to put -4 in these other ones, but these ones aren't zeroing out. These ones aren't creating the root, but these 3 are. So it's -4 with a multiplicity 3. What else is a root? McKenna.
2.
And what's its multiplicity? And lastly, London. What's the last root? 5. And I'm cool with not writing anything, but you need to know that that's multiplicity 1, so you could write it if you want. It is odd. If it's a multiplicity 1, that's an odd multiplicity. Obviously you know that, but it could, 1's kind of annoying sometimes. 2 is even, 3 is odd. Why is that important? Well, depending on the multiplicity of that root, the function behaves differently very close to that root. Now we know it at exactly that root, at exactly -4, what's the function going to spit out? James in the back. 0. We know it's going to spit out exactly 0 at exactly that root. But what happens really close to that point? It's going to be close to 0, but not exactly 0. And what we really care about is it going to be positive or negative? Is it going to be above the x-axis or below the x-axis? Very close to that root. And the thing is, depending on the multiplicity of that root, it behaves differently. So when you go past, we talked about this a couple weeks ago, but in this case, when you get very, very close to -4, let's do one of the positive ones, it makes it easier. Well, no, okay, we have to do better. When you get very, very close to -4, like -3.999, this is still coming out positive. That would be to the right side of that root. But then when you pass through to the other side, to -4.000001, now it's negative. And what happens when you take a negative number and raise it to an odd power? A negative times a negative times a negative, times a negative. So it went through. It goes through this root. It goes through odd multiplicities. Now it kind of behaves like a cubic, it like wiggles through there because when you take a small number and multiply it by itself a bunch of times, it gets even smaller. So the function like gets compressed right there. But it still goes through. It still goes through on odd multiplicities. Something different happens for an even multiplicity. It doesn't matter if it's going to come out odd because the even times you multiply it is going to boost it up positive. Now, whether it's actually above or actually below depends on everything else in the function. So we have to start the end behavior. Okay, so now we're going to graph it. Or sketch a graph. We know we're supposed to start up in the air. Or that's how I think of it. Because as we go further and further this way, the function's going to be high. So we're going to start up here. And what's our first target? Our first 0 is -4. So let's write that in, -4 comma 0. In fact, some people like to just put all the targets on here. So the next target is 2. And then later is 5. So 2 comma 0 and 5 comma 0. Okay, we're coming down from our end behavior. We're getting very close to this root. So it turns out we're above this factor. But we know that root has an odd multiplicity, so we will go through, it's 3, so it does compress a little and then wiggle its way through and then come out the other side. Now it's down here. That's the next time we have to interact with the x-axis, so we're heading towards it, and looks like we have a y-intercept we can figure out later by plugging in 0, and we're heading towards this 2. What's going to happen there? Well, the sign will not change on this factor as we pass through 2 because it's being squared. So whatever side we're on, we're going to stay on that side. The sign's not going to switch there. None of the other factors are going to switch because we're nowhere near those numbers that will make those signs switch. So we have to turn around. We stay negative there. We touch 0 for a second, but then all the answers keep coming out negative as you go to 2.1 and 2.5 and 3 and 4. And we're getting close to 5. We're getting close to our next root. It has an odd multiplicity. It just goes straight through. It's linear. It acts like a line. Okay, it doesn't wiggle this time because it's not cubic. It doesn't get compressed. The sign just flips. It's going on its merry way, and the sign just flips there. And now all the answers are positive, and they're going to stay positive, and the end behavior is up and up and up and away. Does that make sense, Agu? Did you already finish the other 2 from the sub? Oh, no wonder you're mad. How about everybody else? You guys finish the sub stuff? Raise your hand if you're not done. Okay, I'm going to try to give you guys a lot of work time today. How am I doing? 48? Okay, you got 21 more minutes. Okay, we're going to do number 5 together. No, number 4. Pretty good deed. No? How far did we make it? Oh. We forgot to do one thing. Forgot to find the y-intercept. I said we were going to do that later. So you don't have to pull your notes back out. You find it the same way you would always find it. You plug in 0. If you plug in 0, this will be 0 plus 4. 4 cubed is 64. Times, plug in 0, that's negative 2. Negative 2 squared is 4. Plug in 0, that's negative 5. You grab a calculator. 64 times 4 times negative 5. That's not what that says. 64 times 4 times negative 5. Negative 1,280. So what do you notice about this cool graph we made? It is not to scale. And notice there is no scale anywhere. Because it's just a sketch. Everything is pinned down by your labels. We're interested in end behavior. We're kind of interested in the behavior as it goes through, although if you don't get that right, that's okay. Just say we're super zoomed out. You can't tell if it's wiggling or not. Some people call this bouncing off the x-axis, but I don't think of it as a verb. It just is there. The math is there. Although it is kind of a verb while you're drawing it, so while you're drawing it, you can say I will bounce here as I draw it. That makes sense? Okay. Number 4. Degree and, yes, did I not pass you out one? Would you come get 2 for me? By sign, they mean sign on the lead coefficient. So, the sign of the lead coefficient. Now, it's not in standard form, so we don't know what the lead coefficient is. But we can do a little investigation here. To get the lead, we would cube this 2x, which really we only care about the sign. So it's going to be positive. This is going to contribute positive. This is positive 4. Positive times a negative. It's going to be negative. So it's negative sign. Now we didn't do the degree. Let's do the degree. There's 2 powers of x here. They're going to multiply by this one to become, oh wait, there's 3 powers in here. This factor is cubed. So there's 3 powers of x in here, times 2 more, so that's 5, times 1 more, that's 6. So it is degree 6. You just count up the exponents, but don't forget the single exponents because there's no 1 to count. So you have to actually spy these. You have to spy this one here. Okay, whatever. All right, so the zeros. This is something that was not in the notes. 0 itself is a 0 because x itself is a factor. Okay, in fact, it has a multiplicity of 2. If you plug in 0, the whole thing's going to get zeroed out because of this lead factor. So 0 itself is a 0 because x itself is a factor, and the multiplicity in this case is 2. Okay, we need to know what is the number that'll make this 0. It's not so easy right now. I'm tempted to call in a random student, but I feel like they're going to say 1. But what's with this 2 in front? It's messing with it. So what you can do is make a little miniature game of saying, what will make this 0? And then do some algebra 1 for a second. And you realize it's a half. Do you have to do these little miniature problems every time? Well, if you do, you'll notice a pattern. It's the opposite of the back number divided by the front. The opposite of the back divided by the front. So the opposite of negative 1 is 1 divided by 2. 1 divided by 2 is half. So half is a root. Multiplicity 3. And we have another one of those fractional roots that has a interesting binomial. But the shortcut, opposite of the back divided by the front, will tell us that negative 3/4 is the special number you could plug in there to get 0. You don't have to write this down, but I'll just show you that plugging in negative 3/4 into that factor does indeed lead to a 0. Y-intercept. In this case, it's 0. Because 0 is a root, 0 makes a 0. So the y-intercept is 0, 0. And behavior. Oh, so nice of you to join us, Wesley. You only missed the most important notes of the year. No big deal. Alright, here we need to graph it. One thing you can do is put in the zeros first. So 0 itself is a 0. Negative 3/4, and scale doesn't matter, so you can just put them wherever you want. This one's negative 3/4, comma 0. This one will be 1/2, comma 0. Now we have to care about our end behavior. Okay, we should be starting down, because on the left it goes down. So we're starting from down there. This part's confusing to me because the arrow points this way, but then we go this way. That's weird. Okay, what are we going to do with this first 0? Should we bounce off of it? Should we go through it? What's its multiplicity? Kellen?
Huh?
What's the multiplicity of the negative 3/4 0? That's okay. Let's look at the factor that created it. What's the exponent on the factor that created it?
1.
1. Is that odd or even?
Odd.
Odd. So we're going through. Odd multiplicities you go through. In fact, that's linear, so it just goes straight through. Don't even need to worry about wiggling. All right, 0 itself. What's the multiplicity on 0 itself? Isla. 2. So we're going to bounce off it like a parabola. It's going to approach there and then stay positive after touching that 0 for a second. And what's the multiplicity of our last 0? Siri.
1.
I'm going to a half.
Oh, wait. Never mind, I'm out of order. 3.
3. I see. The last one listed. Yes, I shouldn't have said last. I should have said, what's the multiplicity on the half? So if this one's going to wiggle through because it's acting like a cubic there. It gets compressed. And then, but it does make it through to the other side, and then it comes down. All right. The rest of the time to work on whatever you need to work on. Let me know if you have any questions. I'll just be up here grading your test. No big deal. I'm gonna give it to you tomorrow. I don't think I'm done. I'm not done.
I think I need a new paper. So first of all, I think I need a paper. So
Did I do good?
I think so far. Yes.
Okay, and then I have one more question. You can go first.
So first of all, I think I need a new paper. Second of all, I don't really understand what we're doing.
Okay. Do you understand that the factors make zeros?
No.
Okay. Let's do a simple one like this. What numbers did you put in here to make these equal 0?
The opposite of them.
Yep. So same thing here, except on this last one, when you get this 1, notice how that factor is being cubed now?
Mm-hmm.
That means it has a multiplicity of 3, and when you get to that 0, you will go through it like a cubic.
Huh?
Okay, wait, here, do this for me. Okay, ready, Desmond? Go open up Desmos. Hey, it's kind of named after you, Desmond. Open up Desmos and type this in and look at it and kind of analyze it.
But that won't make me help it
No,
understand.
yeah, you'll get it. It'll help you understand.
What if I still don't get it?
Then come back. We'll talk more about it.
So when we like turn in assignments, like when we submit stuff, like assignments and whatnot, like on Schoology, do you actually like open the assignment and look at it, or do you
That's why it
just
takes me
like?
so long to grade it. That's why I have 600 assignments to grade.
Do I
Yeah.
have any assignments missing right now?
You can see that in Schoology.
No, because like, but like if it's really old, it goes away.
Bring me your Chromebook. Go to Schoology. Don't look at us.
I'm not. I am in Schoology.
So you go to this tab, grades, and here. Oh, okay. See that little picture? So I've not graded that, but you have a picture. Picture. Oh, here's one. Graphing exercises 3000. You do not have a picture. These ones all don't have pictures. So yes, these are quote unquote missing. Are any of them due? Yeah, this one was due in November. What is that? Oh, the 4th. So that was due today.
And then also, do you grade for accuracy?
Just check to see if the student filled it out.
Yeah, I have more. I have a lot more. This just made me even more confused.
Okay. There.
What? Huh?
Okay. So maybe I went. Yeah, maybe I went. Oh, I didn't know you could do that. Nice. Dude, you just rocked my world.
No, I didn't. I don't
Okay,
know.
look. What is one number that it goes through?
-4.
That's made by this factor. See, the opposite, like you said, it goes to the opposite. It goes to the opposite here. But then something weird happens at 1, because this factor is being cubed, it acts like a cube as it goes through there. But it still goes through. Still goes through, right? Still goes through there.
Like I said, I need a new paper because also this made me confused because what is this?
Those are the zeros. So,
How are those the zeros if that's there?
okay, so you said that it's the opposite of this, right? -3. And then you look to the exponent on that factor. So the exponent is 1, so the multiplicity is 1. -2, multiplicity 1. But then +1 has a multiplicity of 3. So something weird's going to happen there. Right? What? Right? There's the exponent of 3 on there. Okay. Then we put these on. We put -3, -2, and 1. Then we have to figure out the degree. So let's count up all the powers of x. How many powers of x right here? You check the exponent on the x's and the exponents on the factors.
So there's 1.
1. So that's 2.
1,
But check the factor.
3.
So it was 1, 1, 3. That's 5 total. Check the sign in front.
It's positive.
Okay. So that'll tell us the end behavior. It's odd, so it will go like this. So now we're ready to graph, because we know we're going to start down. We come up, we go through that first one, multiplicity 1. Odd ones we go through that first one. Okay, that was -3, multiplicity 1. So we went to -3, we went through, because 1 is odd. Okay, Negative 2. What's the multiplicity on that one?
2. 1.
1, so it goes through that one. Now we have one more 0 to go through. Okay? It's the positive 1. What's its multiplicity? 3 is odd, so it's going to go through, but it's going to go through wiggly. It doesn't really matter. You can just go through. The last question is, where's this? Plug in 0. 0 plus 3 is 3. 0 plus 2 is 2. 0 minus 1 is negative 1. Negative 1 cubed, though, is negative 1. And we have this 3 in the front, too. We don't want to forget about that. So 9, 18, negative 18. 0, comma, negative 18. 0, comma, negative 18.
Okay. So, thank you.
Here, you can have a fresh one if you want.
But I don't have any more pencils. Like, they're all gone. I don't have any more pencils. All I have is crappy pens. Okay.
By the way, I did finish grading your tests.
Mr. Abden,
Yeah.
is the last one supposed to be negative or positive?
Negative. Number 6 is negative sign in front. I added that to make it interesting. Alright, I can't remember your score, but it's in the next.
Thank you. Hey.
What? Next Monday. It's due next Monday. The heck? That's not right. Where's my little pen? An extra one. Here, you have the one I wrote on. Wait. Oh, you have an extra. They wanted an extra one. Do. Let's see. Let's just do it then.
I will not be here tomorrow.
Okay, you got a decent grade on your test. I think B.
Did I?
Yeah. Yeah. Did I just see it? Yeah, I'll have to find it. But yeah, you passed. You did great. Good job, Mary.
Are there any handouts for tomorrow?
Nope.
No?
Yep. See you later, Mary.
Yeah.
Ethan.
I was wondering if I can have a castle library just so I can look at some of my college assignments.
What? Well, okay. I would say yes, but you need to be here for the notes today.
Oh, your notes. One day you have to be on notes.
That's important.
How unfortunate.
Oh, speaking of which, I forgot to press stop on recording. I mean, I guess you could watch the notes online later.